All right, we're gonna get started. We're a little past 7, so we're gonna get the ball rolling. Tonight we have a very special guest, Bob, and forgive me if I pronounce this wrong, Tegtmeier. He's gonna be doing
Tegtmeier sounds better.
perfect. He's gonna be
That's
doing a presentation on, as you can see, an inside look at the Sperry Rail service from 1999 to the 2000 era. So a little bit about Bob. Um, He's going to be giving a VHS tape presentation with a few other things on the Sperry Rail. Most rail fans know the Sperry Rail, big cars inspected the rails, but how is it done? What defects are they looking for? How many vehicles are there that perform the service? Bob was lucky enough to be hired as the Sperry Quality Assurance Manager in 1999. Being a rail fan and a quality assurance engineer professional, it was a good combination for the time it lasted. Bob was able to ride the cars doing the inspections, help qualify new vehicles, and learn about the non-destructive test methods used to detect the multiple defects that can occur in the actual rail. And he took photos. The program was originally put together for Bob's railfan friends back in 2000, along with a shop tour. It has been updated to give an overview of Sperry Rail during that time with a bit of history and the structure of the company. All the detector vehicle types and test methods are reviewed along with the other services. Sperry Rail performed in the Danbury shop location. There are photos and explanations of what went on during the rail testing inspections, the output provided to the host railroad, and what it was like working on big car and high rail test vehicles. A little bit about Bob. He was born in the Bronx and grew up in Yonkers, so subway rides, watching the New Haven in New York, the later the Penn Central trains, were a big part of his childhood. But it did not stop there. After getting his bachelor's and master of mechanical engineering at Manhattan College, he discovered there were railfan and model railroads at his aerospace employer in New Jersey. He and his friends have been building/operating model trains and rail fanning together for the last 45 years. He has found time to get married to his patient wife for over 40 years, Amy, and he has 2 children, with one being a rail fan. He does not love the other one too for over 30 years. He has operated trains with friends in Connecticut and is working on his L&E model railroad. Now retired, he almost has time to work on it. He has also taken the time to update this presentation. So this very exciting presentation is going to get started. Take it away, Bob, and thank you for taking the time out of your Wednesday
okay.
to present for us.
Well, thank you. I've given this on to a number of clubs and museums and whatever, and well, usually gets a favorable result. Hopefully, that'll be the same tonight. What as I've done this a number of times, I found that I had a VHS tape that the Danbury Railway Museum guys actually digitized, and it's been, they think, yep, show this first, Bob, and then when you do your talk, it'll make a little more sense. So I am going to switch my screen to the video. It's only 8 or 9 minutes, but when I talk about the cars and everything else, you'll probably have a better idea of what I'm talking about. So let me see. Can can you see the screen? Anybody?
We can see your presentation. Are you trying to bring the
Still seeing
video
the
up?
present? Okay, I'm gonna that's what happened last time. We're gonna do it again. And one more try.
So you just want to hit your share screen and select your video and enable
Oh
audio.
yes, yeah, there we go. Okay, now we should be able to see it.
There we
And
are. And you want to make sure your audio is enabled. Bob, you want to make sure your audio is enabled for the video.
I don't hear anything.
Doesn't move the car very fast at all.
How's that?
Because he's responding to signals from a man at the business end of the car. That man is the operator. His main duty is to run the detection equipment that locates internal flaws in the steel rails on the track. That's what we're here for. That's what the work of the detector crew is all about. When the crew is testing rails, the car slowly moves along a section of track, and the equipment generates a graph on 2 tape charts or video monitors. The operator watches the graph on his console and also looks out the window to compare what the graph tells him to what he sees on the rails when they come out beneath the car. He's trained to recognize the patterns caused by normal conditions like joints and welds and other structures. When he sees something he can't account for, he buzzes the driver to back up a few rail lengths and then to stop the car. Assistant operators, the entry position on the detector crew, start out by learning to drive the big car, but quickly move to the testing area. It takes about 12 months of on-the-job training to test rail without supervision. First, they do what's called a ground examination. That's when they inspect the rail for any visible sign of a defect. Another way they inspect the rail is the hand test. They use an ultrasonic scope that lets them determine the size and location of a defect inside the rail, like radars used to locate aircraft. If they find a defect, the operator records the type, the size, assigns it a serial number, and marks the location.
I'm not sure why the video's not playing, but this is what they do to mark the defects. I've seen this enough that I know what's going on.
Back in the recording room, the operator enters the data on the defect into a computer that prints out a report at the end of the day. Once the information is recorded, the crew's ready to continue testing on down the track. This is what goes on throughout the day. In some places, depending on the age of the rail and the tonnage of the traffic it carries, a detector car may only find 1 or 2 defects. In others, 40 or 50 a day isn't uncommon. But the bottom line, as far as the crew's knees and feet are concerned, is this. They have to climb out of and climb back into the car from 60 to 80 times a day in every kind of weather you can imagine. Crew members rotate their jobs as much as possible to allow for training. Maintenance and repair of the car and the testing gear is also the responsibility of the detector crew. These chores are a big part of every working day. They can be tough, strenuous, and dirty. A rail-bound detector car isn't only where the crew works, it's also where they live when the day's work is done. These quarters aren't fancy, but they're a livable home away from home, sometimes 3,000 miles away, for up to 3 months at a time. However, weekend trips back home are sometimes possible when the work is within a crew member's part of the country. The Sperry fleet of detector vehicles also includes high rail trucks, special rigs that can travel on road and rail. High railers can travel independent of the rail lines, which means the crew can drive to a motel at the end of the day. High railer drivers require commercial driver's licenses and medical certification.
You can see that it uses Fairmont high rail gear to put the truck on the rails. And this was actually done at the Sperry Rail test track.
Once
And
the high railer truck is on the rails and when the test carriage is lowered, the work is pretty much the same as on the rail-bound detector cars.
the electronics was a generation newer than the railbound cars. And again, here, the guy is just testing, looking to see if he's got an indication and doing the verification. And doing the marking.
How
This I can
important
tell you is
the work
all
done by Sperry's detector crews. Identifying defects in the track is one sure way to prevent costly railroad accidents. Train derailments can be potentially disastrous, not only to personnel and property, but to entire communities when the freight includes dangerous materials. And don't forget about passengers. Rail testing may not seem heroic at first, but it's no idle boast to say that Sperry detector crews save lives. It's a plain fact that at the end of the day, this is work you can be proud of doing because it matters to every single railroad employee and train commuter in America. Sperry Rail Service is a company with a long history of service to the railroad industry. We've been testing track for over 70 years, and we've checked over 9 million miles of rail. That's more than 20 trips to the moon and back.
Anyway, he's trying to
So
sell
what's the
you
pay?
on working for Sperry.
offers competitive wages and benefits. So beyond wages and benefits, what Sperry Rail offers to the ambitious and self-motivated is the opportunity to become your own boss, the chief operator of a detector car, where you'll have a level of independence and responsibility you won't find in most workplaces. If you're looking for a job that can take you somewhere, from places all over America to places where you're in charge of serious work that matters to people's lives, the detector car may be for you. If you're willing to work your way up, Sperry Rail Service won't let you down.
Okay, that's the rest of the information is where you apply for the job and such. But we're going to go back to the presentation and share that. So it gives you a good overview of what it was like and what it is like on some of the big cars. And you know, I did ride on both the big cars and the high rail vehicles. In addition, I also ran on the subway car down in New York, which was very cool. You know, being away for 3 months, I don't know how many people would actually want to do that, but I've talked with operators and they have done it. And you do get to see the country. You're going to see some photographs. But well, let's get into the presentation, and I will be around. You know, I'll stick around for questions afterwards. You know, if it's really urgent, you know, let me know. But you know, if you can hold it to the end, I'll answer the questions then. So anyway, some background. You know, I actually did write what they read about me. You know, I am a rail fan. I've been doing this for quite a long time, and I worked in quality assurance for 40 years, quality engine and engineering. So this seemed like a great mix. My boss, Tom DeJoseph, he's also a rail fan, but he was the president of the company. And a lot of this information was used in his presentations that I would do on PowerPoint because he wasn't any good at it 25 years ago. So, you know, we did it for CSX, for TFM, for Florida East Coast, just to name a few. In fact, I did a presentation for Florida East Coast, and I called up Florida East Coast. I said, can you send me the image of your logo? And when Tom did the presentation, what the guy was most impressed with, he said, where did you get that image of our railroad? And Tom said, well, my quality assurance manager's a rail fan. He put it in there. They did get the job, so it was a good thing. Mike Shakanowski, he's a world-renowned non-destructive testing level 3. Certainly, I learned a lot from him about ultrasonics. The man is a leader in the field. I think he's retired now, but just a great guy. Dr. Robin Clark was the head of design engineering. I wound up learning from him. He was from England, and we did a lot of presentations together. Alistair Veach, you're going to see Sperry Rail 200. He was the driving force between going into or getting back into Europe where they hadn't been for many years. Really nice guy. I had the shop and operations personnel right outside my door when I was in Danbury. I literally walked around the corner and I could be out in the shop and see everybody and see what was going on. I don't know a lot about today's operations. I've looked a little bit and found out some of the stuff. Obviously, stuff has changed in 25 years, but the basic stuff is still the same. So unfortunately, I did learn about EBIT and EBITDA, and if you don't make your numbers, then they decide, well, okay, you don't have to, we really don't need you that badly. So my employment ended in May of 2000, but I'd done this presentation Tom actually let me have the shop, do a presentation in PowerPoint for all my friends, and then we got to climb around the cars. It was very cool. So I've done it for a number of places. Hopefully you'll enjoy the presentation. And like I said, I'll be around for questions. And if I don't know the answers, I'll make them up. So I actually did the presentation for my friends January 7th on 2000. And yes, there have been many updates since then. I'm not sure how that happened, but let's get through it. So, Rockwood Service Company actually owned Sperry Rail. They were a materials engineering company, and they did inspections on pipelines and many things else, and training. And so they bought Sperry Rail. They said this would be a great synergy. And it should have been. I don't know how good it actually was, but I think there's a lot of infighting between the companies. But I believe they're still working together. And this is how it was set up in 2000. If you go to sperryrail.com, you can see how a lot of things have changed since then. Not sure why that's happened. Give me a moment. I can recover from this. Okay. So Sperry Rail had been around for a while. And remember, Tom would give this presentation to the railroads. So some of this is salesmanship. A lot of it will be technical information for you. So in 1928, there had been a number of derailments, and they actually contacted Elmer Sperry to come up with a way to inspect rail. And the man holds over 400 patents. I think he's second only to Thomas Edison as far as patents. So they've been testing rail since 1928. They say 10,000, back then it was 10 million miles. Today they say 12 million miles, and they'll say that they have today over 6 million internal rail defects that they've detected. So why is this important? Well, rail defects can result in, and these are actual Sperry pictures of derailments. These are pictures that they took at, I don't know exactly where, but they went out and said, well, gee whiz, guys, you had a broken rail. This is what happened. So as far as 2000, it was the world's first company to provide a railroad rail detection service. They were the world, and I believe they still are the world's largest rail inspection company. Some railroads do their own testing, but they contract with Sperry as a second party. Today, they've got over 90 years experience in testing rail. They used to say, when I would read the book, they would say we had 55 or 58 detector cars. It never matched up, but if that's what they said, we're going with 58. That's how many they were there. They also had trained people, AS&T operational staff. These are people who are trained in, the American Society for Non-Destructive Testing, their different levels. So it took 100 people on these vehicles to actually test the rail all around the world. And at the time, they were the only company totally focused on rail flaw detection. Other companies did rail flaw, and they did track maintenance and a few other things, but Sperry's always been focused on the rail flaw detection part of the business. So rail, it's the most expensive track asset in the railroad industry, which I didn't know until I got there. You know, you just think of the rail and it's just there, but it's expensive. And of course, rail can develop internal defects from the steelmaking process and from fatigue. We're going to go through a bunch of the defects and how these things do get detected by the Sperry rail cars. So what causes rail to break? Well, if you've been trackside and you see the rail bouncing up and down on the ties because it's pumping out some of the mud or whatever from the ballast, that's going to do it. You've heard wheel flats go after trains had a nice good slide with an emergency. Those wheel flats just send the shocks right into the rail. You've seen both hot and cold. When you've got hot temperatures, you sometimes see the rail kinks. When you get the cold temperatures, well, you got the exact opposite effect. They try to lay rail and weld rail at a nominal temperature, but if you get really cold, the rail can break. And especially if you've got rail that's been there for many, many years, it wears, the head profile gets worn, and it'll start developing defects from that. And of course, power maintenance. If you go back years ago, you used to have track workers who would run up and down the rail, tightening the bolts. Well, everything that you see now pretty much is welded rail, but those bolts where you still have stick rail, those joints are still going to get loose. And when those things get loose, that's when you start getting the defects, because the joint bars get loose and things can happen to the rail. And of course, the one thing that could not be detected is the internal defects from manufacturing. Rail detection, when rail is made now, eddy current tests the rail as it goes through, but they didn't have eddy current when these things were put down 50, 60, 70 years ago with the rail. So you've got older rail that may have more defects in it. And it's not to say you cannot get a defect even if it comes out good from the factory. So what are these rail flaws? Well, you have an XY plane, you got horizontal and vertical defects. In the head, from engine burns and things like that, you can get horizontal defects that are called transverse defects, which you can see it's the 70-degree thing here. It can be from defects from manufacture. It can be defects from having shelled rail and things like that, and you'll get vertical split heads, horizontal split heads. So initially they focused on the rail head when they first started doing testing because they had induction. But that's not the only rail defects you can have. You can have bolt hole cracks, which we just talked about when you've got loose joint bars. You can actually have defects inside of the web where it'll actually split. And you can have separation of the head and the web. We're going to show you some pictures of that. So there's a lot of different things that can happen with the rail. And if I had pressed the buttons, I would have said you can have all of these particular defects. And I think I got most of, and then of course, then there's weld defects. We're going to talk a little bit about weld defects. So yes, transverse defects in the head, horizontal defects can be anywhere in the head or the web. The bolt hole defects, the cracks, the star cracks, we're going to take a look at all of them. So transverse defects, okay? That's a pretty ugly looking defect that probably grew from a little defect in the center. And this is a transverse defect. This will usually happen in the head, or it happens in the head, and it'll grow over time. It may start off, they'll actually measure how big the defect is with ultrasonic checking. If it's a small defect, maybe they'll leave it until next time. A defect like this, they're going to take it out. A compound fissure is what you see down here. This is where you get more than one defect, one transverse defect, and it goes in different directions. that's the kind of stuff that causes big derailments. But these are the head defects that you really you can't see unless you're looking at the ultrasonic or the induction method. The detail fractures are sometimes caused by when you actually get a defect from too much wear on the rail, it'll actually go into the head and generate one of these types of defects. And the reverse is very similar. So what happens is, as you're running on the rail, the way that the defects go in, you'll usually find that these things are at a 10 to 20 degree angle. They're not usually flat. They usually are at an angle against the normal flow of rail. And that's important when we take a look at how do we detect some of these defects. But we've got more. Horizontal defects. Well, a horizontal split head. Well, yep, that's a pretty horizontal split head. And this is an actual cut where the rail just separated. Could have been caused by wear, most likely wear. I was going to change my mouse, but I didn't. And now I'm sorry I didn't. Okay, vertical defects. A vertical split head. I'm very familiar with this defect. You can see how it's exactly what they're saying. It's in the head and it's got a vertical split. And there you can see it from the top. When I was out on the railroad, on Conrail out in the Pennsy Middle Division, there was a vertical split head that ran for about 10 or 12 feet. And what'll happen is the rail will just fall down eventually. It'll just crack right off and you'll be only riding on half a rail. So we did replace that rail when I was out. That was my big highlight going out. So these are some other defects, and I've seen the cracked rail. You can see where the head and web separation is. I had never seen a piped rail, which is where the rail actually pipes in the web. And I was talking with one of the guys who actually worked for 2 years at Sperry, and he says, Bob, we really did come across these defects. Well, you may get this visual, but boy, that's going to be a tough one to find. So these are actually, real defects. And of course, the bolt hole cracks. These are, there's a bolt hole crack, and this is going to be a star crack coming up here. And it's interesting, Sperry actually donated this picture on the right. They donated that rail to the Railway Museum when I was there. But remember where the bolt holes are. They're hidden underneath a joint bar. And without ultrasonics and induction, you're not going to find these things with a visual unless you actually break through the rail. But you notice how the cracks tend to go at a certain angle. You see them kind of propagated at an angle. That's important when you're looking for the defects and you're using your ultrasonics. We'll show you a little bit more about that in a moment. And of course, weld defects. I've seen weld defects that completely left the head. It just, the upper part here, when they put in the thermite, it put a big bubble in here, and you don't know it till you check it. And the problem with weld defects is, well, when they occur, they'll occur before it's visible. Many of these are not visible at any time, but the growth is exceptionally rapid or sudden once it develops. And when it does, it's a complete break through the head and the web. So weld defects, factory welds, they're really good. The thermite welds are really good. But if you don't get a complete weld, it's a complete rail break. It's not going to be something slow like the transverse defects and things like that. So how do we detect these defects? Well, there's an induction inspection method, which is like an eddy current inspection. And that does a lot of the surface and subsurface of the railhead. And then there's the ultrasonic inspection technique, which is non-invasive. It's really a lot easier to understand and see than is the induction method. But these are non-destructive test methods, meaning, yes, you run along, it doesn't do anything to the rail, but you get your information while you're testing. So how did this all start out? Induction was started by Elmer Sperry, but it was actually Harcourt C. Drake, who actually holds the flaws. So if you look back in the 30s, he's the guy who actually came up and implemented Sperry's system. And really, it's putting a current into the rail and then having a coil detection to see if there's any irregularities. Just like when you're looking at magnets, and if you disturb the field, everything goes all over the place. Well, they developed a way to use a coil to detect defects and come to a chart recorder that would show you, hey, there's something going on. How these guys came up and were able to get defects back in the 20s and 30s, it amazes me. But there they are. That's some of the stuff from 28 and from 30, the early Sperry cars. And then in 59, they added ultrasonics. It actually came from Germany, but they had started hand testing in 1949. And they used something called a roller search unit. They're calling it a wheel probe, but it's an RSU, a roller search unit. And what they do is they have a pulse echo method that is used where you'll send a pulse in to the rail and you're going to get something back. And if it hits a defect, like here, you can see a bolt hole crack and you can see this is a 45-degree check. Oh my goodness. That's going to find your bolt hole cracks if they're exceeding the outside of the actual bolt hole. When you're checking the head of the rail, the angle of refraction, when it goes in there, well, you're going to shoot it with a 70-degree transducer, and that 70-degree, when it goes in, will check the heads. So that's a very handy thing to have. And your 0-degree transducer, well, that's really good because you're going to expect when you send a pulse in, it's going to show you that there's a 7-inch high rail. When you hit a bolt hole, well, you expect that. But if you are not in the area where there's a bolt hole and you're going to hit a horizontal crack, well, it's going to come back and say there's a defect at 1 inch or 2 inch. So the roller search units and the way the ultrasonics work, it's much more intuitive. So Sperry rail, when you're testing, they're inspecting both rails at the same time. There's mirror images of the test equipment on both rails, and they have multi-defect detection capability like I've shown you. What I was surprised in one of the presentations, it's like, well, I don't know how they detected bolt hole cracks before they had the ultrasonics because the induction focused on the head defects. So maybe it picked it up, maybe it did not. So it inspects the rails without removing the angle bars. Very important. And the other thing that Sperry does, every time they test a rail, they get a permanent traceable record. They have the world's largest defect database of rail defects and rail testing. When I was there, they had rooms full of paper tapes going back to the 30s. In 1999 and 2000, they had paper tapes, and they also had a computer database. They were in a transition, and we were just learning about access and things like that and how to do these things. There was some magnetic tape on some of the cars, but when they had to go back and find a defect, they had to go back to the railroad, had to go back to the milepost marker. And if you had a defect that didn't show up, they would be going back reading the tapes. So it was labor intensive. How good is it now? I don't know if they've digitized all that information. This is a very busy screen, and I'm going to go through it really quick. But this is what is going on when your rail detector cars are going along. There's an encoder that you set at 0 or whatever the milepost marker is, so you know where you are. With the ultrasonics, every 1/6 of an inch, you're sending out a pulse to check for a defect. For the induction, you have wipers on the rail and a coil checking on both rails, and they're feeding into the signal processing units. So you're getting inputs from both RSUs, from both of the induction coils, it's being processed and something's coming out, the paper tape or the computer tape. That information goes into if you're going from analog to digital, it's being processed in the computers and the old computers that you saw in the back. It's giving a real-time display or paper tape so you can see what the defects are. When a defect is detected, well, Sperry Rail has a paint marker that's going to hit the rail and say, here's a bunch of yellow school bus yellow paint that's been diluted. It marks the defect. So when you have to come back and check this, they know where to back the big car up so they can get up and do the hand checks. And of course, when there's computers and when there's data, they can put it into storage, and they'll also generate the reports from that, either by hand or from the computer for the railroad. So it's a busy graph, but it gives you an idea of what goes on. Well, I talked about this roller search units, and so these are the omnis. They have a bunch of names for it, and I only know why they call some things. I'm not sure, but they call this the Omni. Now, what's important about this is a Dow Corning tire that is filled with fluid. It's actually antifreeze, and then they put water onto the rail so that you can shoot a pulse from you can see in here, there are these different colored transducers. Well, the zero transducer goes from here and shoots straight down, and it'll catch any horizontal defects. So that's a good thing for the zero. If it doesn't give you a 7-inch rail height and something bounces back, you know you either have a bolt hole or you have a defect. The 37-degree transducer, when it comes in, remember how I said the bolt holes kind of get like 37 to 45? Well, that 37, when the angle goes in and it hits the rail, it goes in and bounces back the same way, but this is the optimum angle to pick up bolt hole cracks, and that's why they use a 37-degree transducer shooting into the rail. The 70-degree transducer over here, that's going to go into the rail and cover the rail head. So remember how I said that they're kind of 10 to 20 degrees instead of being normal to the rail? Well, that's kind of like the optimum angle that they will detect some of those transverse defects or whatever's in the rail. So this is going to roll, there's going to be 1 or 2 of these on each rail, and they'll be feeding the signals into the signal processing. Now, as if that wasn't enough, they also take transducers and they shoot across the rails so that they can also cover the head and catch any of the rails. And they call this the DF-RSU, and I don't know what DF stands for. Well, to make it even more bulletproof, they wound up putting all these transducers into one roller search unit, and they called it UX9, which I can tell you it's ultrasonic ×9 roller search unit, because they've got 6 70s, 2 37s, and 1 0 crystal shooting into the rail, so it really covers your rail for detecting the defects. Is it perfect? No, but it was the best roller search unit that had been that Sperry had come up with. The only thing is you had 20 channels. Well, if I've got 18 channels, I'm kind of running out of space to process my signals. So they've had to update their signal processing capability. Well, we talked about having the strip chart display. So this is going to kind of show you, this is what an operator is seeing. And remember, he's going backwards. he is looking at the rail in the distance. It's always traveling, so he's seeing what defects are there. This is his view from the back. So he can see that there's a rail joint here. Now, digitally on the paper tape or the computer display, well, this is going to be the equipment analog response. So the middle one is always going to be your either side, your induction. And you can see if this is the rail joint here, well, there's my rail joint right there. I'm picking it up with induction. We know there's something there. When I'm looking ultrasonically, ultrasonically and induction wise, you can see the left rail, there's nothing there. So I'm not getting any indications on the left rail. That's these over here. But on the right side, I can see, oh, look, this 0 is probably telling me I got 6 bolt holes. So that's probably your 0 transducer looking down. The 37 and the 70s are showing you there is something going on, but I'm not quite sure what it is. Well, what the digital equipment is doing, it's showing you what these defects are. It's interpreting everything for you. So you can see there's nothing on the left rail because there's no defects there, but here's all your defects on the right rail. And since none of this is out of the ordinary, the operator would say, you know what? I got 6 bolt holes. I got a rail joint. This just goes on. I don't have to do anything. But this is what they watch for at 13 miles an hour, max speed. They are constantly watching this. So how are the rails checked? What are they using? Well, when they have the rail-bound vehicles that go out, and those are the big yellow cars that you've seen. And this was actually my picture. We were on the MBTA, and we were being passed by an MBTA train. And then there's high rail vehicles we talked about, and that was out in Pennsylvania on SRS 804, and we happened to see an Amtrak train pass by as we were working on the other train, on the other track. So you always have a railroad person with you because you have to be given the track warrants to go out and test. The only thing that's different with the Sperry rail vehicles is you don't have to contact a dispatcher to move backwards, where if you backed up your train, you would have to get permission to do that. But they have to operate just like any other railroad vehicle. This is just something, I did send this out. This is the history of, from 1995 of all the rostered cars that they had at the time. And there is updates that you can find online. This is available if people want it. I sent the PDFs to the 470 Club. So if you want to see the history of the roster, this is it up to 1995. So you'll see stuff that where the history came from. And the reason I have all these extra marks is because at one time, Canadian Pacific said, you have to put all your cars into the UMLR database, and you've got to put on the transponders. So all the cars that were in Canada got transponders, and one of the things that you had to do is make sure you got the right history. I actually had to write some of the historical societies, the CNW and stuff like that, to find out the true build dates on some of these cars. So anyway, it's something that's available to you if you'd like to it. But how do we do the rail testing? Well, Sperry rail flaw detector vehicles identify defects before they fail. That's the important thing. So you have the 100 series cars, which we call the big cars. You have the high rail vehicles, the 800 series, and you'll see later the 900 series. Sperry 200, a unique vehicle that was built when I was there. It got shipped over to Norway, but it was a beautiful car and it had a lot of features that have been incorporated in vehicles since. And you also had hand testing or you could do hand testing with these 300 series push carts. So the 100 series. The unique thing about this at the time, it was the only dual test system available in the world. They had both induction and ultrasonic complementary systems. You saw how the tapes work. All right. You got 13-mile-an-hour testing speed, and that's physics. That's why you were limited at the time to 13 miles an hour. You could never go faster because you'll put a pulse into the rail. By the time it came back, if you went more than 13 miles an hour, you couldn't catch the pulse. A lot of these cars were doodlebugs, but a lot of them were built specifically for Sperry in the 70s and the 80s. They would run, they were diesel electric, and they would run 50 miles an hour. That was the advertised speed. I did have somebody tell me that he did 55 on these things. And they were self-contained. The crew lives on board, and if you're in an area in Canada up in the hills where there's not a hotel or the mountains where there's not a hotel, it comes in very handy. So CP was very big on having these things. Some of them had bunk beds, and some of them were, you had up to 3 bedrooms. Now, I was lucky enough to get on a car with a bedroom. The only thing that I wasn't lucky about is that's also where the tank for the holding tank was. So they had to come in my window with the honeysucker and take out, kind of like draining your septic tank. I guess the other bad thing is if you happen to be in a bunk bed and there's somebody who has some issues with his whatever, you don't want them being above you. So anyway, 12 induction channels and 20 ultrasonic channels. This is what most people are familiar with. This is what you get from Walthers. It's they've been around for a long, long time. Since the 30s. So I told you that the cars have to go along. They test when they get a defect or an indication, they have to back up and hand check every defect. Well, that really slows down the testing. So what they came up with, Sperry came up with, is they got a chase car. So the chase car would be getting the information sent to them by radio, and they would do the hand checks so that you weren't backing the car up like you saw in the video. He'd signal the operator to go back up, so he would do the hand check. They would have instead these Chevy Suburbans with the Fairmont rail gear and the ability to test. They would do the hand verifications, so it would allow the big car or the high rail vehicle to continue testing while he's doing the verifications. And then the data was transmitted by radio back then. I don't know, the production rates, they still say 10 to 13 miles per hour. It certainly eliminated a lot of backup moves. Today, they can upload everything to the cloud. That I did check when I was looking at the new, they do the same thing, but everything is uploaded into the cloud, and that's how they transfer the data. But this was a Sperry initiative. It was something new that Sperry had done. So there's your big car with the chase car. They really just, again, what I said, they have nonstop vehicle operation, and it definitely would speed up the testing. And the customer would have to opt for this if they wanted it. Sperry didn't give anything away for free. Now, the high rail vehicles were initially, the ones that I saw were built on Ford chassis, and then when Ford sold it to Sterling, they were built on Sterling chassis. The obvious advantages of this is it's easy on and off track. You get to a crossing and you can drop the gear and go on and test. But same speeds testing, can only do 30 miles an hour, and you're doing 30 miles an hour on this truck and it starts wobbling. You know that you don't want to go any faster than that when it's run light. And of course, normal highway speeds to get off the track when you're off the track and when you're going to the Motel 6. They didn't give you a lot of money for the motels, trust me. So the ability to leave the track crossings made it a lot easier for the railroads. You didn't have to go look for a siding to dump the big cars in. You just came to a crossing and off you go. So again, they were only ultrasonic because they hadn't perfected the way of putting the induction onto the cars. Most of them had electronic strip chart, but the first couple were made with paper tapes. And again, with the, this looks awful familiar, doesn't it? Let's try this. 800 series with the chase car. Sometimes they would build like 827, 826. They were built in pairs. They didn't have to stay married that way, but you can see 624 is paired with 824. It just gives you another view of the cars. They had narrower tire and tread so they could run on the rails, and they had the equipment to do the testing. And again, we talked about the chase car verification. It's definitely it definitely helped. But if you're modeling and if you want to simulate track inspection, figure a good part of your track will be out of service if you're running your railroad and you want to make believe, I'm sorry, you want to operate Sperry cars or Sperry vehicles. So here you say, oh, Bob, how come you've got this picture? When this was created, all I had was the picture. They were actually building the 900 series in the shops. And what the 900 series did, it now combined ultrasonics and induction. The high rail vehicles have a generator that generates all the electricity separate from the engine that runs everything in the cab. This is all built, custom built here. Everything is custom built. It's just put onto a truck chassis. And well, this was for Tom DeJoseph. He's selling this to the railroad because this is now, this is now your sliced bread. You've got it's even better. So he was very impressed that I could take a PDF and do this. But there was something else that came along from this, and they had been developing this. I showed you the pictures of the paper tapes, and I showed you the picture of the computer tapes. Well, they now went from A scan to B scan imaging. Now, what the B scan was, it was a step up. So if you're looking at this particular, I hope you can see the mouse. You can see there's a defect here. You can see that you've got bolt holes and everything else. What the B scan image was a much better imaging of what the defects are. So you can see that there's actually over here, it may be a little small, but it's showing the defect in relationship to the bolt holes. So this made it easier for the operators to see stuff. And then it also led to neural nets, which I'll talk about a little bit, in a minute. But they started this on 403, and this was the big technology leap in detecting or taking the inputs and making them easier for the operators to see. So here it's being built, and this is me walking out, just before I'm done at Sperry, and you can see they are building 901. So this did go into service. And like I said, this whole cab this whole box was made by an outside vendor. Every cabinet was made at the outside vendor. This was fabricated in the shops. They had, full machine shop capabilities and things like that. And this was the very first one that was being made. So when Tom went and was selling these things, or he wanted to sell it or tell him what's coming down the pipe, hey, nobody else offers these features on a high rail vehicle. And the first one was going to be available in July 2000. Well, I left in May, so that's why I didn't get to see it. And again, it had the dual system, the flexibility of the high rail operation. And, in addition, 12 induction channels. First time you've got induction on the cars. B-scan presentation, which is probably the most easiest, was the best thing for operators so they could see, took less time to train people. Again, nonstop testing vehicle. They said they could have a chase car available in 2001. Did it happen? I don't know. I wasn't there, but this was selling the 900 series, but they still have the same test speed. Go figure. All right. So I did a little update. I did some research, and they built at least 10 of these vehicles. And now Sperry has a 950 series, and all of those are dual mode. So apparently this is what they're building and selling for today. If you go to the trainweb.org at Sperry HTM, you can find out a lot of this information. It is there. It's a wealth of information. It was kept up until 2010, but you know, if you go there, you'll find a lot of information. You'll even see some of my pictures that I did, you know, 25 years ago. They're on this website if you're interested in finding out more about the Sperry cars. The 200 series vehicle, isn't that a beauty? So again, this had real-time defect analysis, the B-scan. It was the highest tech thing that Sperry had put out since the 403, which you're going to see. It took out everything, the actual trucks that the probes ran on. They guided along the rail, so they weren't shooting off at an angle. They actually were tracking the rail. It was pretty cool. They were going faster, so they had a high-speed marking defect system. They could actually do 26 miles an hour. And where all the trucks you've seen and all the vehicles you've seen only test one way, you could go to either end of this car and do the testing. So it was bi-directional. You know, you didn't have to turn it in order to test. So 40 kilometers per hour, which is like 26 miles an hour, and they could test 75 to 100 miles a day. And what did they do with it? Oh, and it had the B-scan reporting. So we're really, you know, this is the cat's meow. They shipped it over to Norway, and it's been testing in Europe ever since. It only tested, this is in the Danbury Railway, where the Danbury Railway Museum is today. All the pictures were taken in Danbury, and they loaded it on a boat and took it over to Europe. And this did increase their European presence. And I know a number of things have been changed. When you went into this, it was nice, it was luxurious, it was air conditioned. Some of the other cars you'll see were not quite like that. I never would have advertised this thing, but this is what they call their walking stick. And this could test single rails. It could test your frogs, so you didn't have to go over back and forth. It was good for testing switches when you had to do a short distance for a low cost. I never actually saw another 300 series there, but there are a number of walking sticks called out on that paper. And you can see it has an ultrasonic unit. It's got coupling to go onto the rail to make sure that you got the tire making contact with the rail. You've got a rail flaw detector to look down here so you can see what's going on. And I don't know what you're doing with this thing, but anyway, that was for doing small amounts of rail. You certainly wouldn't want to do the main line with this thing. In the past, there were other push carts that they had. Fairway backed up on me, but we'll try again. All right. So hand testing. Damn it. Darn it. Okay. So here you can test the rail, but in order to verify if you've got a defect, you would do the hand testing. So this was the absolute ultimate rail flaw detector screen. They used to use cathode ray tubes, and then they used some like HP type stuff. Well, they went to liquid crystal display, and you can see the guy is using here, he's checking it with an ultrasonic transducer, and he's like, oh, I can see the bottom, but I can also see the defect. Well, this was really wonderful for, it was a great step above for rail flaw detection. And I'm I know I'm talking about hand testing in these, you know, if you're testing small amounts of rail, it's good. Well, anyway, these liquid crystal displays, they were great until they took them up into North Dakota and Canada, and the liquid crystal display froze. So they had to go back and pull out the cathode rays. So I just wanted to bring that up. But this is hand testing, and you'll see another example of how hand testing is done. So the New York City subway was tested by Sperry Rail 403. And this was before 200, this was their big test bed. It had B-scan technology. They had tapes that they read, and they went and verified the defects the next day. It ran through the subway at night, and they would send people down in the subway to test the rail the next day. So it was a kind of unique looking vehicle. It was a Mack rail bus, and we'll see a few more pictures of it. They had to build 403 because when they were testing rail in Detroit, 402 burned up. It got stuck, and the traction motor, they had a fire, so they had to build a new one. But these Mack rail buses were actually bought by the New Haven, and they were never successful. Dumaine didn't want to use them, whatever. So they bought 10 of them, and they kind of floundered around. But it made a great rail testing vehicle. And you can see that this had the B-scan, and what was new about this, it was using technology called a neural net, which we know today as AI information. And the neural net was interpreting the signals that you saw. This was the computer that said, oh, I see a line here. I think this is what you have. So it made it very easy, or much easier, for them to call out the defect. Then you had to go test it by hand. So this was part rail detector car, part science and development. Now it's been retired because the Transit Authority bought their own car, and it's supposed to go to the Danbury Railway Museum. It hasn't gotten there. So again, I told you it was originally a Mack rail bus, and they still had the Mack engine in it. New Haven sold them to Remington Arms, and they transported gunpowder in the plants. So here's a few more pictures of 403 in the shop. Well, the first time they built one of these things and they put a cutting torch to it, well, that gunpowder didn't always stay exactly where it was supposed to. I am sure that the guy had to change his shorts the first time he lit up the gunpowder and had a big spark on this. It was, they weren't expecting it, and supposedly it was a huge flash. And after that, they were much more careful when they were making modifications to these. But going through the subway, you had these big lights. You could see the cut and cover method. It's like I wasn't caring about looking at the displays because that was kind of boring. But what you could see going through the subways was just amazing on this car. And it's a diesel-powered car. That's what it is. So a very cool machine. So how do we do our testing? Well, the 100 series, the 200 series, the 400 series, you got to travel by rail to the railroad to do the testing. The 800 series, you drive on and you hop on and hop off the rails, and that's what the 900 series was doing. Again, indications are checked by hand. You get an indication, it has to be checked because it's considered a defect until you verify it. Now, this guy is not lifting the truck on. It just looks like it. That was us getting on at Lewistown, Pennsylvania, onto the main line. And you pull it up to the rail crossing, you drop down the gear, and off you go. And then here's the rail testing. You can see he's got his reflectoscope here that shows the rail flaw detectors. They used, for the couplant, they didn't use water, they used diesel fluid, diesel fuel, because it made a good coupling. Well, they told us you can't use diesel fuel because it's not environmentally safe. Well, whatever. They told us to go get baby oil. So we went into CVS. There were three of us. I was on the car, and he says, "All right, you want baby oil?" We bought them out of baby oil, all the Johnson and Johnson. And the women that's checking us out is looking at us like, "What the hell are these guys doing?" Sorry, what the heck are these guys doing? I said, "We're testing rail," and that was it. She just burst out laughing. But what happened was the baby oil, when it got cold, also froze. So my guess is they're still using some sort of diesel fluid to fuel to check this. When you find these defects, well, Sperry finds them and they mark them for the railroad so they know what needs to be done. Now the railroad takes over and makes decisions on how to take care of the defect per FRA safety guidelines. So if you have a little defect, you may leave it in and you'll check it next time. If it's a bigger defect, you shut the your rail is already shut down. You usually have your truck right behind you, and they will cut the rail out or the defect out. You'll take it, you'll mark it, and it's not unusual to see the rail being cut up and replaced the same day, which is what we saw. You got a two-track main line. Well, you can divert rail traffic to the other side. You can cross it over. You got a single-track main line. You definitely have to take the rail out. So, and people ask me, well, how often is it inspected for rail flaws? It's specified by the classification of the track and the amount of tonnage per year that goes over that. Some track is actually inspected twice a year. If it's a light rail and you don't get a lot of traffic, and you can actually, you do not have to test it ultrasonically. You can actually do a visual inspection if you're running on like 5-mile-an-hour rail or something like that. But that's how it's determined. Now your commuter lines and your Amtrak lines, twice a year. That's a given. So passenger rail, figure twice a year. If it's 40 megatons per year, twice a year. After that, it will vary. What else did Sperry do? Well, they maintained the 55 detector vehicles from fabrication. And now you're looking at that. What is that? That was the shell for 200. They built it in the shop. And they commissioned the new vehicles, and I was there for the new vehicles, both of these. So, they were building new vehicles. And of course, they're also maintaining the fleets. Now, they had a shop out in Kansas City. They had a shop in Danbury. The Danbury shop is closed. I believe they're doing something in Beacon or something, or further down the line. But they can perform, or they did perform, complete refurbishments. Now, here was 145 when it came into the shop, and that's it when it came out. It was more than just a paint job. They replaced all the windows. I mean, people need to live on this. It needs to be updated. You've got your prime mover, you got traction motors, you have auxiliary generators that provide the power for the equipment for you to living on. And these are pretty unique. No two are exactly the same. So yeah, when these came in for a shop for an overhaul, they got an overhaul. And they also had technology development. They did a test simulator so you didn't have to learn everything on the car. We showed you the chase car inspection. That was what they developed. They developed high rail induction. The neural nets, this was something that came over from England. These guys knew that this was the future. You needed to have a better way of classifying and detecting the inputs into, well, what's wrong with the rail? And again, the new testing techniques. So there was your neural nets. That was already in place in 2000. Now this clown here, he looks very competent, but he has no idea what he's doing. And the reason is because it's me, and 25 years ago, and they needed a stand-in to show somebody working on the test simulator. So what they did is they set up this, and this is the guy who did know what he was doing. They set this up. This is the view that you saw, and he's looking at the rail going down. And when he sees a defect, he's practicing marking them with a light pen on these computer tubes. And these are glass tubes. We're not talking flat screens. This was ancient technology from today, but it worked. And you can see there's the light pen. You have this is what you would see on the detector car, your analog and your digital displays, but now you could take the light pen and actually put the defects in so you didn't have to write it. But I didn't know what I was doing. I was just the happy face. All right. When the railroad requests an investigation on a rail service failure, Sperry Rail Service will respond. They had 6 rail investigators that reported to Carlo Patrick, who was the manager of field investigations. They were on call, especially if there were accidents, and you would get the Sperry Level 3 involved if there was really an issue that needed to be addressed. So yeah, when you had derailments, they would have to respond on site, take a look at what's going on, take a look at the defects, and okay, well, now that you guys are all experts, you know that this is a transverse defect, but it was caused from the rail wearing on the inside, and that's why you have these marks. So they would make a thorough review of all the records. And remember, Sperry had that big database of paper records. They'd have to go back and check those. They'd have to check and see what the operator had written down. They would check and see what was actually documented, and they'd go back and pull the actual tape, and maybe go back further to make a determination. Okay, why did this rail break? What was it that happened? And then they would write an investigation. The railroad got the whole story, good and the bad. Carlo Patrick, he's the one that had to sign this. This happened to go to Ron Bright at CSX, and he explained what he saw, what happened, and why this happened. You know, who's at fault? Well, that's a determination made between the railroad and Sperry. I told you about those paper tapes, but, you know, now you got all this data coming in, because now you're starting to get computers and whatnot. And you can see we were using Microsoft Access to you know, make up these things. And I learned it so I could do database reports. But to send out computers, specialized reporting and transmitting the stuff to the client, we had to have a business support in the development area that would take all this information and send it out. Daily transmission of the car production data, monthly statistical reporting, you know, by knowing, you know, where you had more defects and things like that, you could better assign when you were going to do your testing. So having this to help the railroads and help Sperry was very important. You know, your data management for preventive planning maintenance, very, very important. And I will tell you that 25 years ago, you know, I could do databases. Anybody could do databases, but, you know, we sent everything out on email. Now everything is done with tablets. If you go on the Sperry website, everybody's got a tablet, and that's what they keep that handy for everything. But we're talking 1999, 2000, and here is a Sperry Rail report that went out for the month of January 2000 for the car number 824, and they had 22 days of service, but they only tested 17. But the railroad, they pay. If you can't get the car out on the railroad, that's your tough luck, you know. But you want to know how well or you know, how much testing are you getting for your money? So if they see that they're not getting enough testing done and they're paying for the car, well, maybe they'll make sure they make that time for it. So this was the month report. And what's interesting is when you look at the miles tested during the day, well, you're going anywhere from 7.4 miles to 57 miles and a tenth. So there's quite a big, you know, depending on the defects and depending on the condition of the rail and depending on how long they let you out, you may get a lot of testing done. So when they said 40 to 50 miles a day, yes, it could happen, but you see here, and the average per day was actually 23 and a quarter miles tested per day. And then they have the average speed of 12 miles and defects per mile. but this gave you a better idea of what the condition of your rail was and, well, what's it going to look like next month if you're running on the same line. All right. Sperry also ran an ultrasonic training school. I talked a lot about the RSUs and I talked about the hand testing. Well, how did people get trained in this? Well, Sperry ran the ultrasonics testing at the Danbury site. It was open to the railroad personnel by invitation. And I also took the course because, well, I thought it'd be a good thing for me, and it really was. It was very interesting. It was 4 days of class and a day of testing. Testing was interspersed. You would do some while you were there. So again, practical testing, and it only focused on railroad applications. And here you can see this fellow has got a reflectoscope there. He's got a transducer in there in his hand, and he's going to be checking this rail for a defect. So every rail had a defect in it. You'd have to go in, determine what the defect was. You saw we had a couple of them. Not only would you have to determine what the defect was, you would have to make sure you sized it correctly. And, well, the only way you could do that was by doing the ultrasonic checks. So there were a lot of rails that were there, and you had to pass the test. They covered the defect so you couldn't see it, and you had to go and get like 10 of 12 right, because nobody gets them all right. So you were sizing them, telling them what the defect was. If it was a bolt hole crack, they didn't want you looking and saying, oh, it's got a bolt hole crack, I know what this is. So you really had to learn how to use your ultrasonics, your testing, your angle of induction, of reflection as it goes in, trying these things. Out of the 10 people that were in the class, there was only one person that got every one of them right. And I know that person stayed 3 hours longer than anyone else, but that person was determined to complete the test. And I did get them all right, but I never had enough experience to earn my level 1. I wasn't out on the railroad, but the learning the ultrasonics and the NDT helped me in my future jobs. Sperry also worked with the FRA to develop rail standards. Well, they were the ones that would tell the rail FRA people what's the smallest detectable defect. And again, the rule, once you got a suspected indication, it's been recorded, it has to be verified by hand because it's always going to be a defect. So these were things that Sperry insisted on. This is how it had to be done. And again, in many cases, the suspect that's verified, it is removed immediately. Sometimes they would leave them in if they were small, and they said, well, we're going to catch them next time. So I must have been doing something because they did hire me as the quality manager. So, I came in and I had been fresh from working in, I was working on at Honeywell and a number of other places. And I had implemented ISO 9000, if you guys were familiar with it, and continuous improvement. So that was my job to kind of do it. So I made up the quality policy, which I appropriated from my previous job and just changed Sperry, the name, and made it more rail oriented. And then Tom DeJoseph wrote the letters to the company and said, yes, this is going to be the greatest thing since sliced bread. And we did write procedures and things like that. I also edited the Sperry newsletter that went out to all the employees. I put on the AEI transponders for the freight car movements in the UMLR database. And I did Tom DeJoseph's PowerPoint so he could give them, get the business in. So I thought I was in good shape. But again, then I learned about EBITDA, and it's like, well, if you don't make your EBITDA numbers, they don't need you. So we improved the work instructions. It promoted testing efficiency, safety, and customer satisfaction. So you'll notice that I actually updated the detector vehicle safety manual. And then there was the chief operator evaluation procedure so that everybody would do it the same. I mean, there were improvements made in the time that I was there because I had done this before. But you might say, why did I update the safety manual? Why me? Well, you may be surprised by the answer. So Tom would be, after he goes through all this stuff about the cars and everything, and he didn't have all this stuff I had in there, You know, he would be saying Sperry Rail service, growth oriented. We're going to do international. We're going to be doing high speed testing. We're going to be doing chase car technology, which they were. They were doing neural nets, which now that you know a little bit about it and what was going on, it's a selling point because the other people that were doing rail testing did not have it. And high rail induction. So this is what he's, you know, it's all his selling stuff. You know, he's telling you that we're a technology company, that we've been providing service for over 70 years, owned by Rockwood and Synergies, sister companies involved, the shares and resources, poised to grow. Now, Sperry was in Danbury, Pandrol Jacks was in Danbury, and there's another guy who makes rail detector cars in Danbury. So poised to grow, they did grow. In 2002, Rockwood bought up the competition, Pandrol Jackson, which you know better as Harsco Track Technologies, also located in Danbury, and they got 25 cars. So of course they grew. They got all of their business. Now, some railroads do their own testing. They don't want to have anything to do with Sperry. They'll buy their own cars from the other guy in Danbury who builds them. So Danbury is kind of like the headquarters of track testing in the United States. But I talked with Tom, and he says, yeah, it was an easy sale because Pandrol Jackson really wanted to get out of the business. So it didn't take much. He said it was done in a couple of months. But that's certainly how they grew. And again, they did grow in Europe by bringing the 200 over there. That was a very good selling point. And, you know, they do have other vehicles over there. So I was on Sperry 134. Well, I'm sorry, I was on 138, which was very similar to 134. And you saw some of the pictures in the video. So this is what when the driver is driving, I never got to drive. This was his view. This is in the back of Sperry when they were in Danbury. And he would drive along at 13 miles an hour, or if they're making a light move, he was in charge. But the operator would ring him if they found a defect and he had to back up. So this is what the operator, what the driver saw. This was the view from the operator's cab when he's looking at the track going out. And you may have noticed Dave Chatterton is the guy who was doing all the training. He's up and down those ladders, 80 times a day. The man was seriously bow-legged. I don't know if it was just the going up and down or if he was riding horses or whatever, but it certainly didn't help. This technology was from the 70s. I worked on aircraft that used these same technologies, but they were still using this technology into the 2000s. They were called green boxes. Here's your beds. You had 4 bunks. They weren't always occupied. Usually there were 3 on a crew. And well, if your hygiene wasn't good, you may not have liked it too much. This is the paper tape. So there were paper tapes that would run down here, and you had to change the tape before it ran out so that you wouldn't lose your continuity. And well, they used these tables for many, many years. And I don't know if they're still using them, but all those paper tapes that were curled up, they're in storage somewhere. There's your high-tech VCR and 25-inch television. You couldn't drink. You were not supposed to have alcohol. I saw they had cigarettes there, but you were not supposed to drink. And your kitchen, you even had a nice window over the kitchen sink so you could look out while you were washing the dishes. And you did meal prep. One of the stories that I heard is like, well, when the inspectors would come out, the old hands or the guys who had been there for a long time, they knew how to hide their alcohol. How did they hide the alcohol? Remember, I told you there was a paint pot there? They would wrap the alcohol up into plastic and seal it up, drop it into the paint pot when the car was being inspected, and then when the inspector left, out came the alcohol. So I you know, you read stories about what happened on the railroad years ago, how people did drink regardless. Well, it didn't change from what I was told. I didn't drink on the railroad, and I did have to get drug tested, even though I was in the office most of the time. The first week I was there or second week I was there, said, you have to go for a drug test. I said, but I don't. Well, I passed. But that Sperry employees were required, just like railroad employees, they had to be tested. Now, I talked about 200, and this was a very attractive car. You saw that they built the body in the shop. Well, how did they get the running gear? Well, there was an SRS 147 they wanted to retire, so they took the body off of that, and they made the changes to the chassis so that it would be upgraded, and then they dropped this on the 147 chassis. So you won't find a 147 today on the Sperry roster because it became 200. But it was a very, very, air-conditioned, nice cars. You saw what the 134 looked like. This did not look like this. This looked like, Motel 6 to a Marriott, for sure. And again, the testing, how they did the 26 miles an hour, I'm not sure to this day. I don't know if they would tell us or whatever. But yes, to be able to test 26 miles an hour, that was a big deal. So 138, I told you I did ride on it in the MBTA. That was the first big car I got to ride on. 810, that was one of the earlier high rail vehicles. There were accidents. This did get scrapped. They told you down here that you could see the world. Well, here you're testing in Montana, and Reuben Fairchild took this photograph of the elk running on the track. So you did get to see the world. Now, this particular picture is now where Metro North has got their car shops for cleaning MU cars down on the Harlem River. And you can see the back here, you can actually see the bridge that goes over that carried the aqueduct. Well, I was driving along and I saw this and I said, well, I'm going to go stop. I was going up the Major Deegan. And I met the crew, I talked with them, and I found out some interesting things. Now, remember what I talked about the safety manual? Well, let's continue on, but just keep this in mind that Metro North has 600 or maybe it's 700 volts DC on the third rail. So kind of important to know. This is a picture of the Sperry rail drafting, how the cars were painted until 1967. I took it because it was a linen drawing. It's actually hanging up behind me. And if you want this or the roster, I did send copies of this to the 470 Club, so they have it. Walters contacted Sperry looking for drawings of the big car. That's why I have that. But I couldn't find any. They were so unique, I didn't have an actual big drawing of what the cars looked like. So what they did is they wound up going out and scanning one of the cars and getting the dimensions that way. Now, Walters made a nice Sperry car. I put a Digitrax 120 DZ 126 decoder and LED lights. It works very nicely. Walters did 2 runs of these, but apparently the gears break, and they did a couple of paint schemes. Hallmark did a brass car. They did 2 runs in the 70. You might find some on eBay if you wanted to put it on your model railroad. So here's mine. It's actually up on the shelf. I can look at it from where I am. And, well, you saw the pictures of it. They did a pretty good job of doing that. So if you're a model railroader, yes, you can get a Sperry car. I did not put sound in it, but, there's plenty of room to put decoders in. It's very accurate, and I should have painted the handrails black, but, well, I didn't. So I also saw this at the Big E show this year. If you were looking to do the Sperry Rail trucks. So the original trucks I told you were Fords and Sterlings when I was there. The chase cars were always Chevy Suburbans. But this guy did a really nice scratch build of this. This was in the Dayhill guys. I asked, I said, who did this? And they couldn't tell me any information. But you can model a Sperry Rail truck. Yeah, and again, once Pandrell Jackson, they merged the fleets. So, okay, we're still awake. I hope some people I can see are dozing. But why did I update the safety manual? When I was in the Bronx taking the pictures of 149 next to the third rail, one of the new guys asked me, "What was that?" I said, "You don't know what that third rail is?" He says, "I have no idea." I said, "Where are you from?" He said, "Iowa." Well, okay. Well, I looked in the manual and it said, don't climb on top of the cars when there's, catenary involved. But they were doing the subway, they were doing Metro North, and nobody knew that was, the subways, that was 600 volts. And if you happen to ground yourself, you're going to die. So I thought that would be a good thing to put into the safety manual, and I cleaned it up. But that's why I did the safety manual. I actually saw the problem. So anyway, I got time for questions. If you have questions, I want to thank everybody for allowing me to present the material to you. I hope you've enjoyed it. It's been now 25 years since I've done this, but it's what I remember. And again, I hope you enjoyed the presentation. If you want to contact me, I'm at rtegtmeier@cox.net. And that's the end for now. You all get a fill in the blank diploma. Thank you.
Bob, thank you very much. It was a very interesting presentation. We really haven't had something like this before. A lot of people think when railroads are being built, it's build the track, run the trains on it, replace the ties as needed. But, there's a lot of upkeep to this stuff. So, learning about this is really cool and, something that not a lot of us understand happens. We normally do at the end. I know you said you're good for questions, but we open up to about 10 minutes of questions. If anybody has questions, now's the time. We're going to start our timer and yeah. We're not seeing any, so
All right.
Actually, I
Again.
have one.
Oh, good.
Whatever happened to damaged rails when they are replaced due to the defects?
They wind up in a scrapyard usually, unless there's a court case or something that needs to be the railroads handle it, and it's all done per FRA guidelines. Sperry finds them, but they never take the rails out. It's always the home railroad responsibility to take care of that and keep the records of the rail.
Whether it's Norfolk Southern, CSX, Union Pacific, etc.
Yeah, they make the determinations. Do they need it? How many defects do you need to cut in the section and show? But yeah, Sperry wouldn't have anything to do with the actual rail. They would, when they needed defects, they would go to the railroad to say, hey, can I get the rail, and then they could cut and show it. I mean, I do have one one piece of rail that Sperry gave me here that I usually, if I'm doing this live, I point to the head and stuff like that. But yeah, it's for liability cases and things like that. The railroad, I imagine, must have a certain amount of time that they have to keep their records. And I do have one thing. Remember, I told you that you always had a railroad representative on your cars. Didn't matter if you were on the MBTA or the New York City subway or the when we were doing the the Pennsylvania, well, what was the Pennsy Main, which was Conrail, you always had to have somebody from the railroad on the line. Now, you saw that we had an Amtrak train come down, as you saw us by 8:04. Now, you would think that the guy that they put on the train that, you had, he would be, he was there for 24 years in Conrail or whatever, and he would know what to do. Before that train came, that Conrail guy was walking down the middle of the gauge on the other track, and that train was coming downhill. Now, if there was if we were on a commuter railroad or something like that, and we saw a train coming the other, anywhere, you would always yell, "Hot rail, hot rail." This guy's walking down the middle of the gauge. You didn't even hear the thing. If we didn't yell hot rail, he would have been, he wasn't showing good safety practices. So, sometimes you are on your own. That's just a story I can relate because nothing happened. Everything was good, but sometimes things did happen.
I guess there are a number of safety tips and regulations.
There was a bunch of stuff in the safety manual. You never stop on the top of the rail. I mean, there were things that we knew. We had to steel-toed shoes, and you always had to have, if you're on the car, you had to have boots above your ankle. If you take a look at some of the old Sperry tapes from the 40s, you saw guys in suits and ties and just regular leather shoes jumping off these trains at speed. We were told you wait for a complete stop, which nobody did, but that was the rule. And you always had safety glasses on and a helmet. And that was really a pain in the ass because every time you'd bend over to go take a look at the rail, the helmet fell off. But that's what the rules were.
Gonna do
And-
last minute questions for Bob. Any last minute questions out in Zoom land or here in person? Not seeing any. So Bob, again, thank you very much. We appreciate your taking the time out of your Wednesday to give us this excellent presentation. You'll be hearing from me and Eric Grover to potentially get you back on the books for another date down the road. So again, thank you very
All right.
much. And everyone on Zoom land, we're all set. Have a good night.
Thank you very much.